It is the continuation of part 2. Travels through surface of liquid. Example, water waves, ocean waves. The tsunami is the example of the surface wave because it has the spherical and elliptical path. You can pause the video and you can write it down. This surface wave. Longitudinal. Transverse wave. Question number 6 and 7. Describe wave properties like amplitude, energy of a wave, wavelength, speed, phase, period and frequency. We can discuss one by one. Amplitude, it is A, maximum displacement from equilibrium. So here is the maximum displacement from the equilibrium at the center. Here is the maximum displacement at the point. And it is always positive. Larger amplitude has more energy in the wave. Now, this is a smaller amplitude, smaller energy, larger amplitude, larger energy. Doubling the amplitude. If you double the amplitude, energy is quadrupled, 4 times bigger than the previous one. If you double the amplitude, energy is increases by 4. Okay, because energy is proportional to amplitude square. You can pause and note it down. Next, energy of the wave. It depends on amplitude, as we discussed before. Waves with larger amplitude transfer more energy. So amplitude is big, large, and energy, it has more energy. Example, strong winds, large water waves. If there is a strong wind, it will create a very big water waves. If there is a gentle breeze, it creates a smaller waves. So energy related to the amplitude. Wavelength, it is lambda, unit is lambda, not a unit, sorry, the symbol is lambda. Distance between two successive crest or trough. Here is the crest, here is the trough. Now two successive crest is, the length is called the wavelength lambda. At the same time, two successive trough, the length between two successive trough is also wavelength. And in the longitudinal, this region is the rarefaction region and this is the compression region. Compression to compression, the distance is also called the wavelength. Wave speed, same like a normal the speed formula, distance by time, delta d by delta t, change in distance in the change in time. Depends on the medium. The wave speed depends on the medium. It does not depends on the amplitude, frequency, wavelength. It depends on the medium. Example, sound travels faster in the warm air than in the cold air. It depends on the medium, not depends on the amplitude, frequency, wavelength. Okay, because you see the air medium, both of them are air. One is the warm, another is the cold. The warm air, the particles move faster, so the speed of sound is faster. Phase describes a relative position of the particle in a wave. 2 points are in phase, same displacement and velocity. 180-degree out of phase, opposite displacement and velocity. You can pause and copy. Period T, time period, time for one complete cycle of a periodic wave. equal to the period of the source producing the wave. Applies only to periodic waves. So if the simple pendulum starts at this point, back and forth, it takes some time, and this is a time taken for one cycle. Frequency, number of cycles per second. Related to period, it is inverse proportional. Frequency inversely proportional to time period. If frequency is doubled, time period is halved, like that. If you know the frequency value, you can find the time period. Time period is equal to 1 over frequency, 1 over to 0.5 seconds. Quick exam memory version. Amplitude, size of the wave. Wavelength, length of one cycle. Speed, depends on the medium, not wavelength, amplitude and or frequency. Phase, relative position of points. Period, time for one cycle. Frequency, cycles per second. The unit of amplitude, meter. Unit of wavelength, meter. Unit of speed, meter per second. Unit of time period, seconds. Unit of frequency, hertz. We have a question. Calculate frequency of a wave from its period and vice versa. As I told you before, if you have the period like 10 seconds, you want to find the frequency, write 1 by t, 1 by 10, 0.1 hertz. If you have the frequency 10 hertz, you want to find the time period, 1 over frequency, 1 over 10, 0.1 seconds. Now we have a graph, displacement distance graph, graph number 1, displacement time graph, graph number 2. From the graph number 1, we can find lambda and also amplitude we can find. The wavelength from the crest to crest or trough to trough. So the crest points start at 0.4, ends at 0.8. So 0.8 minus 0.4 is equal to 0.4. Or you can subtract 0.6 and 0.2, also 0.4. What is the amplitude? The height of the wave, this one, from the mean position. So the answer is 0.2. Unit is meter. You have to check here. Maybe centimeter, millimeters will be there. You have to check always the axis, the unit in the axis. Now in the graph 2, it is the displacement time graph. Here we can find the frequency, time period, amplitude. In the first graph, we can find the wavelength, we can find the amplitude. We cannot find the frequency, we cannot find the time period in the graph number 1 because the time information is not mentioned. In the graph number 2, we cannot find the wavelength because the distance information is not mentioned. From the graph 2, how are we going to find the time period? The time taken for one cycle from crest to crest. The time starts 0.1, ends 0.5. The time difference is 0.5 minus 0.1, 0.4 seconds. And you take the reciprocal or apply it in the formula 1 over t. 1 over 0.4 is equal to 2.5 hertz. Now we have three questions. 21. How does the frequency of wave change when the period of the wave is doubled? As I told you, period is doubled. That means the frequency is halved. So you can see here, old frequency 1 over t, the new frequency 1 over 2t. So you can separate this 1 by 2 here, half, and you see here 1 over t. What is 1 over t? It is the old frequency. So I replace 1 over t with f0, old frequency. So what is the answer? The new frequency is half of the old frequency. That's what I mentioned. If the time period is doubled, frequency is half. You can pause and copy. Question number 22. Describe the change in the wavelength of a wave when the period is reduced by one half. Okay. Now we can solve like this. Period t is halved. Frequency is doubled. If the frequency is doubled, wavelength is halved. Here is the concept, easy concept. You can remember this in the examination. The time period is halved. Frequency is doubled. If the frequency is doubled, the wavelength is halved when the speed is constant. And you can pause and write it. This also. Question number 23. If the speed of a wave increases to 1.5 times its original speed, while the frequency remains constant, how does the wavelength change? If frequency is constant, we should know speed is directly proportional to the wavelength. If the speed is increased by 1.5, wavelength also increased by 1.5. That is the answer. Very simple. It is mentioned frequency is constant. So V proportional to lambda. If V is increased 1.5, lambda also is increased by 1.5. So you can pause and you can copy it.